See the case of two parallel resistors R1 and R2, and the total current flowing through them is I. The current will be divided in the parallel circuits. Let the current flowing in R1 resistor R1 be I1, and the current flowing through resistor R2 be I2, and the voltage applied across them is V. Okay, then how are they related? The current flowing through I1 can be expressed in terms of the total current. Similarly, the current flowing through I2 can be expressed in terms of total current I. Let's find out the value of I1 in terms of I. I1 is nothing but V by R1. I2, according to Ohm's law, V equal to IR, so V by R2. The voltage will be same across the parallel resistors. The current will be divided. In series circuit, the current will be same, voltages will be divided, voltages will be different. The total current I is nothing but I1 plus I2. Applying KCL at this node, incoming current is I, outgoing currents are I1 and I2, so the total current I will be I1 plus I2. I is what is I? V by, no, we want I1 I2 in terms of I. So let's proceed in a different way. What is I? I equal to V by R equivalent. What is R equivalent? In a parallel case, as we know, 1 by R equivalent resistance of the circuit will be 1 by R1 plus 1 by R2, or 1 by R equivalent is nothing but R1 R2, here R2 plus R1, or R equivalent is inverse of this R1 R2 divided by R1 plus R2. This is R1 only. Okay, so it is V by R equivalent. So V equal to I into R1 R2 by R1 plus R2, I into R equivalent. So substituting the value of V in I1, what we get? I into R1 R2 divided by R1 plus R2 into 1 by R1. R1 will get cancelled out. This becomes I into R2 by R1 plus R2. What about I2? I2 is V by R2. So I into R1 R2 by R1 plus R2 into 1 by R2. R2 will get cancelled out. So this becomes I into R1 by R1 plus R2. Surprisingly, the total current divided in this parallel case in this way. I1 equal to the current flowing through any resistor, one resistor R1 will be total current into opposite arm resistance R2 divided by the total resistance R1 plus R2. Okay, so we can define the current flowing in this way. Current flowing in a parallel resistor equal to total current into opposite arm resistance divided by total resistance, sum of the resistors. Okay, so this rule is famously known as current divider rule or current division rule. Okay, let us solve some problems related to current divider rule. This is the problem. Circuit consists of two resistors, 6 ohms and 3 ohms, connected, not commented, it is connected in parallel and takes a total current of 12 ampere from the supply. Calculate the current through each resistance. Okay, what is given? R1 is given 6 ohms, R2 is given as 3 ohms. Total current I is 12 ampere. Let's apply current division rule to find out current flowing through 6 ohms. That is I1 total current into opposite arm resistance R2 by total resistance R1 plus R2. I2 is 12, R2 is 3, 3 by 3 plus 6. So 12 into 3 by 9. 3 3 is a 3 4 is a. So 4 ampere will flow through 6 ohm. What about current flowing through 3 ohm? That is I2. Again same. We can also find the current flowing through 3 ohms by applying KCL at that node. I minus I1 using the formula I equal to I1 plus I2 or I2 equal to I minus I1. To remember current division rule, let's apply only current division rule. I into opposite arm resistance R1 by total resistance R1 plus R2. 12 into 6 by 6 plus 3 9. 3 2 is 3 3 is 3 1 is 3 4 is. So 8 ampere. I1 plus I2 is 12 ampere. Okay. That's it. Let's solve another problem. Two resistors 4 ohms and 6 ohms are connected in parallel. Okay. Connected in parallel. The total current flowing through the resistors is 5 ampere. Find the current through each resistor. Okay. This is the problem. Let's solve it. R1, let's take R1 as 4 ohm, R2 as 6 ohm. The total current I is given as 5 ampere. First let's find out I1, current flowing through 4 ohms. Total current into I into opposite arm resistance R2 by total resistance R1 plus R2. Okay. So when the value of I is 5 ampere, R2 is 6. This is 6 plus 4, R1 plus R2. 5 into 6 by 10. 5 1s are 5, 5 2s are 10, 2 1s are 2, 2 3s are 6. So this is 3 ampere. What about I2? I minus I1. So 5 minus 3, 2 ampere. Let's use current division also. I into opposite arm resistor R1 by total resistance R1 plus I2 R2. 5 into 4 by 6 plus 4 10. 5 1s are 5 2s are 2 1s are 2 2s are. So 2 ampere. Okay.